14-2, geometric sequences. Okay, here is a sequence. This one's actually a geometric sequence. Here's how you find what we called the common difference in arithmetic sequences is called the common ratio in geometric sequences. Remember, geometric sequences have to do with multiplying and dividing. So, to find it, we're going to start here and go 2 divided by 6. Well, 2 divided by 6 is 1/3. Then 6 divided by 18. 6 divided by 18 is also 1/3. So we're finding the common ratio. 18 divided by 54, 1/3. 54 divided by 162, 1/3. So the common ratio, which is really the same thing as the common difference, only this is geometric, is 1/3. So if I wanted to find the next number, I would say 2 times 1/3. Here's another one. What's happening here? If you can't figure out what's happening, start at the end and go backwards. 7 divided by -7. 7 divided by -7, that's -1. -7 divided by 7, that's -1. Pretty soon, you see it's -1. Now, most of us can look at this one from the front and go, oh, 7 times -1 is -7. -7 times -1 is 7. So sometimes you can figure it out frontwards, but if you can't, start at the back. So the common ratio is -1. Now, if you had to find the next term, what would it be? -7. Okay, let's see if this one has a common ratio. 14 divided by 11. That's 14 over 11. 11 divided by 8. 11 over 8. 8 divided by 5. 8 over 5. 5 divided by 2. You see anything in common there? No, so this is not a geometric sequence. This lesson is going to start out very much like the other one, where it asks you, is it an arithmetic sequence or not? This one's going to ask you, is it a geometric sequence or not? To be a geometric sequence, you must have a common ratio. Okay, just like the lesson of the arithmetic or arithmetic sequences, geometric has a formula also to find a term that you don't want to have to list it all the way out to find it. It's called the nth term. So, in this one, it's a little bit different formula. N still means the number of the term you want. A to the first still means the first term, but instead of a D, this one has an R. R means common ratio, just like D meant common difference. So, problem number 1 says find the 14th term, and here's the sequence, 3, 12, 48, 192. So if you start going backwards and dividing, you're going to find out that the common ratio is 4. Okay? So, let's put everything in the formula. Start with a to the n. We want the 14th term, so that's a to the 14th. And then what's the first term? A to the 1. A to the first is 3. And then we're going to multiply that times r. What's our r? What does r mean? Common ratio. R is 4. And then this one has an exponent. See the little n minus 1? So 14 minus 1 is our exponent. So to work that, the first thing we do is 14 minus 1. So that's 13. So we got 3 times 4 to the 13th. Okay? Now, 4 to the 13th, you're probably going to have to get a calculator out to do that. because really there's really not a good way to do it without a calculator. So that's perfectly fine if you want to do that. Get your calculator or find a calculator and go 4 to the 13th power. We'll talk about how to do that in class. And then multiply it by 3. So this part goes first, then get that answer, multiply it by 3. Here's the total answer to the whole thing. It ends up to be 201,326,592. Wow. Can you read that number? That's 201,326,592. That's actually the answer. That's crazy. So, the good news is, on this section of the book, you are allowed to use a calculator because we're going to need one. Okay, let's try this one. Remember, here's our formula. It says to find the 12th term. Here's the sequence. So first, we need to find the common ratio. Well, 48 divided by 24 is 2. 24 divided by 12 is 2. It's going to be 2. 2. This one you could probably see frontwards. 3 times 2 is 6. 6 times 2 is 12. So it's 2. Okay? So let's fit everything in the formula. So we want a to the 12th. Well, that equals a to the first, which is 3, times r, which is 2, to the 12 minus 1. So that's 2 to the 11th. So 3 times 2 to the 11th. Now, I don't have a calculator right here, but I could probably figure out 2 to the 11th, maybe. Let's see if I can. Okay, 2 to the 11th means 2 11 times. So let's write down 11 twos. There's 4, 5, 6, 7, 8, 9. Well, there's 9, 10, 11. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2, 128, times 2 is 256. Look, that's where I have to start doing some math on paper. So, times 256 times 2 is, let's see, 12, 11, 5, 12. Okay, so let's see if I'm at the right place. Okay, let me go back. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64, 128, 512, 1024. So 1024 times 2 is 2048, so I need 2048 times 2. 2048 times 2. 16. Are you starting to see why a calculator is a good idea? 2 times 4 is 8. That's 9. That's 0. So 4,096. So that's crazy. Now, that's just this part, the 4,096, because that was 2 to the 11th. Now we have to multiply that by 3. I don't even know if I have room to multiply that by 3. So let's see. 4,096 times 3. 3 times 6 is 18. 3 times 9 is 27. That's 28. Okay, 3 times 4 is 12. So there's our answer. That's craziness. Although, we might have one more 2 than we needed. I don't know. So that may not be the right answer. You'll have to go back and check my math. Find the right answer on that one. Without a calculator. But you can use a calculator. But, you know, if you use a calculator and you say, Miss Stephan, I got the right answer, I'm going to say, did you use a calculator? Anyway, that's the general idea of how you do it. It's a lot like the lesson we did last time. So let's have some fun, exciting video homework next. Okay, here's your video homework. Find the common ratio for number 1 if it's a geometric sequence. And number 2 is different directions. You're going to use the formula and find the 8th term. Have a lovely, beautiful evening.